This video is for review quiz 2.7, which is all about functions and their inverses, also one-to-oneness, things like that. For this first problem, we're looking at two functions that we're trying to figure out if they are inverses or not. And the way we do that is we compose each one into the other one. So f of g of x and then f of x, and then g of f of x, I should say. F of g of x, which is the same thing as this first part in part A. And then we also find g of f of x, which is part B. So I'm going to take g of x and plug it into f of x. So f of x is 6 over x minus 5. And then instead of writing the x, we're going to plug g of x into there. So 6 over x plus 5, that's g of x, plugged into f of x. Now what I'm going to do is simplify. These parentheses don't mean much, so I'm going to just drop them. And you see plus 5 and minus 5 cancel. Then we get 6 over x. This is a division of a fraction, so we can multiply by the reciprocal. 6 over 1 times x over 6. And then the 6's cancel, giving us just x. All right. For g of f of x, same process. G of x is 6 over x plus 5. And we're going to plug f of x into that. So we're going to have, I like to make the main fraction a lot bigger than the other fractions. So we're going to have 6 over x minus 5. Once again, we have a division by a fraction. So we're going to multiply by the reciprocal. 6 over 1 is going to be 6 over 1 times x minus 5 over 6. 6's cancel. Oh, there's also a plus 5 there. And this whole thing becomes x minus 5 plus 5, which of course is just x. And that's what it means to be inverses of each other. If you plug one into the other, you get x, the variable back by itself. You have to make sure you test both cases. If one of them fails, then they're not inverses of each other. But these ones do. They both give you x at the end, so that's good to go. Okay, moving on. This function is one-to-one. In other words, it does have an inverse. A one-to-one function is one that passes the vertical, sorry, not the vertical line test, the horizontal line test. So if I were to graph this thing, it looks something like this. It would be up here at 7. And you can take a horizontal line wherever you want. Let me do some different color. A horizontal line wherever you want, and it only ever crosses it at one spot. That means that this function has an inverse, and we can find it. To find it is very simple. I'm going to first change f of x into y, and then I'm just going to flip the x and the y. So we get x equals y cubed plus 7. Now all I'm going to do is solve for y. So first off, let's subtract 7. We get x minus 7 equals y cubed. And now we can take the cube root of everything. That gives us y equal to the cube root of x minus 7. Okay, let's check it. And it works. So if you were to take, I can actually rename this thing instead of y, I'll rename this as f inverse of x. That's how it's read, f inverse of x. And if you take f of x, f of f inverse of x, you will see you get x. And then if you take f inverse of f of x, you will also get x both ways. I encourage you to try that out on your own, and you're going to see that it's going to work out nicely. All right, let's move on. Okay, this one also is one-to-one, therefore it has an inverse. And this one we're actually going to test. We're actually going to show that they are inverses. So f of x equals the 12th root of x. This one looks something like this. It's going to look something like that. And if you take a horizontal line anywhere through this, it will always only cross once. This thing does look like it does flatline eventually, but it doesn't. It actually will keep creeping upwards. It's just slow to do that, and it will never flatline. So then a horizontal will only ever cross it once. So we're looking for the inverse of that. Once again, change that to y and flip x and y. So x equals the 12th root of y. And then all we have to do is take the 12th power. Now this is interesting what we have right here, because the 12th or x to the 12th looks like this. It looks something like this. It's not exactly the same thing, but it's the general shape is right there. And this does not pass the horizontal line test. Therefore, this is not 1-to-1, and therefore it does not have a inverse. However, if you'll notice from the previous graph that I drew of this one, you'll notice that this starts here at the origin and goes up like this. That means all we considered here was x greater than or equal to 0. So for this one, if all we consider is the positive side of the x-axis, so x greater than or equal to 0, so this the right-hand side, then we actually get rid of that left-hand side, and this is a horizontal. This does pass the horizontal line test. And this is the same thing as the inverse of the function. So sometimes you have to exclude the domain to a certain portion. That's because some functions that we work with, especially parabolas, x squared, x to the 4th, x to the 6th, these do not pass the horizontal line test. So we have to exclude the domain. Real quick, I also want to show you the graphical representation of inverses. So this was x, see, it's 12th root of x. And I showed you that this is the x to the 12th, only the positive half of it. And you can see how these are inverses. If we take a straight diagonal line, this diagonal line is y equal to x. So it's a linear function that's goes straight through the origin at a exact 45-degree angle. That's y equal x. The inverses will always be reflections over this line. That's how inverses are found graphically. You just reflect it over that line and you get your inverse. So this also shows you why we only consider x greater than or equal to 0, because that's how it flips. Okay. All right. We must consider only the positive. Or sorry, this is less than or equal to 0. We want greater than or equal to 0. So part C, it cannot be for all x because I just showed you it does not pass the horizontal line test. So we have to only consider the positive. If we looked at the negative, only the negative, we would get this. And let me go back to our original function. This was our original function here. And as you can see, this is not a reflection over the y equal x, the red dotted line there. So this is this is the incorrect portion of the inverse. So we have to take only the positive. That's what we're looking for there. Okay, and this of course is just x to the power of 12. Okay, and now we're going to put f inverse into f. So it first wants you to plug in that. And then we're going to simplify. Of course, we have, I'll just show you this. The first one says f of f inverse of x. The same thing as f inverse we just found was x to the 12. And then of course, f of x is the 12th root. So it's the 12th root of x, but we plug into this x to the 12. So plugging that into there. And those cancel, giving us just x. The same thing happens the other way around. F inverse of f of x gives you f inverse of f of x is the 12th root of x. So we get F inverse is just the 12th power. We have the 12th root of x to the power of 12. Those again cancel, giving us just x. So we've proven that they are inverses of each other by doing this algebra here. It's just x. The equation is verified. All right, last problem. X squared minus 10, x greater than or equal to 0. We're going to find the inverse because this is going to be 1 to 1. Then we're going to graph them and use interval notation to show the domain and range. So first off, I'm actually going to graph them because I want to show you the similar type of argument that we had in the previous problem, why we consider only the positive side. So x minus 10, that looks something like this. We're only considering the positive and equal to 0. It's going to look something like this. It's going to be a parabola. Let me make a better one. And now we want to consider the inverse. So I showed you that the inverse is the thing that goes along this line here. And if we flip this, you're going to see that this point here at the bottom is going to go somewhere around here. And then it's going to look like this. And that's completely reflected across this red line, right? These are all reflected across that. So that's what we expect for the inverse, whatever that function is. So we know that this one is 1 to 1, the first graph that I graphed there, because it passes the horizontal line test. So we can find the inverse algebraically. To do that, we're going to take f of x equals x squared minus 10, change that to y, and then flip x and y. Now we can solve for y. So I'm going to add 10, x plus 10 equals y squared, then take a square root. So we get y equal to the square root of x plus 10. That's the inverse. X plus 10. I actually already showed you the graph. That's what I did up here. So we expect it to look like B, I believe. Yes. Then the domain and range is the most interesting part here. So we don't have to worry about really anything else. Oops. Back once. I can just get rid of that green line. We don't have to worry about anything else besides the domain and range left. The most important point here for the domain and range is this point, because this point kind of shows you where both the domain and the range start. It's easy for the first function because that point, when x equals 0, we have f of 0 gives you 0 squared minus 10, gives you negative 10. So this point is at 0, negative 10. So we actually know that the original domain for this first function, I'm just going to ignore, let me draw this one in blue. I'm going to talk about the black function and the blue function. The blue one's the inverse, f inverse of x. And the black one is the regular function, f of x. So we have the domain of f of x. I'll do f of x. The domain starts at 0 and goes up to positive infinity. It's only the positive side. That's what we had to restrict it. You can see that right here. It says x greater than or equal to 0. That's the same thing as the domain of the function. So that's the same thing as this. The range, you can see, the lowest point that we have on the graph is at negative 10 here. This is the lowest point, and it only goes up above that. So we're going to start at negative 10 and go up to positive infinity. It does go to positive infinity. It just keeps going up and up and up and up and up. So that's the domain and range for the regular function. What's interesting is that the inverse function is the same thing as the domain and range of the original function, just flipped. So the range of the original function is the domain of the inverse. So we can do 0 to infinity. And the range is negative 10 to infinity. And that tells us, you don't actually need that to tell you that, but it tells us that this point is at negative 10, 0, because that's where the domain starts for the inverse function. And then, of course, this does, in fact, keep going up to positive infinity. It just goes there very slowly compared to the original f of x, the black function there. Okay, let's check it. And that's correct.